All right. Welcome everybody to the first Senior JS Dev webinar. I'm so glad that you could join me. Let's go ahead and get started. For this first webinar, what I wanted to do is first of all talk about the goals of webinars in general. What are they for? What are we trying to accomplish with them? The goal of webinars for me is to share content about becoming a senior JavaScript developer, including tips, techniques, and principles. So make it very interactive. That's where I wanted to start with today's webinar, is just talking about senior developers' responsibilities. I'm sure this will become a multi-part webinar topic, but I just wanted to jump off and get started. Senior developers' responsibilities are very different than junior developers' responsibilities. And with great power comes great responsibility, as Spider-Man taught me. So this is the way I like to think of it. Boiled down is basically junior developers are responsible for creating functional code. That means working code. I don't want to confuse the term functional with functional programming, and it's kind of an overloaded term, but this is what I mean by functional code. It's just code that works, code that you can run it and it'll get the job done. A senior developer, on the other hand, has more responsibility than a junior developer. Senior developers not only write functional code, but they need to write maintainable code. And we'll get into a lot later about what maintainable code means. But for now, just think of it as code that can easily be expanded upon, bug fixed, tested, those kind of things to make sure the quality is high of the application. And finally, an architect, his job or her job is to build applications that scale well. So as the business needs new functionality, or perhaps like a whole new business vertical, or some component of the application gets rather large. Think of like a shopping cart, or maybe an accounts page that grows and grows and grows, and suddenly, it takes a whole team to maintain this part of the website. Well, that needs to be scalable, and that's something that an architect job is to make sure that those things can actually happen and still maintain good quality. So there is more responsibility, and so senior developer, making code maintainable might seem like a lot of work, but really once you understand the basics and the fundamentals and you get some practice and some exposure to them, it's really not that bad. The upside to being a senior developer who writes maintainable code is that you get to sleep well. You get good peace of mind. And I like this quote about why we code quality. It's because we code as if the person who ends up maintaining your code is a violent psychopath who knows where you live. So let's all sleep better at night and code so that there's a low ratio of WTFs per code review. All right. Now let's dive in a little bit deeper into what maintainable actually means, because it can be kind of nebulous, can be a little bit confusing. And so I want to nail it down to some principles and some exact points. Mostly there's three parts we can talk about for maintainable code. The first one is clean code, and that usually revolves around conventions of the project. We'll talk about more conventions later, but they're often things that are either unwritten or perhaps written down in like style docs. But there are ways that you can just intuitively go through a code base, and know where to find things, and how things are named, etc. And it's just kind of like tidying up your workspace. It's just a clean area to work, and it's organized. The next part is testable code. Testable code is different than functional code because usually you're employing some kind of a pattern in order to test isolated modules and functionality apart from the whole system. And this is a really good way to make it testable. Again, we'll talk more about that. This is just an overview. The third part is visible code. So this talks about like documentation, commenting, things that you do sort of outside of the code, at least the statements and functions, to help developers understand your work and why you did it. It's really a big part of visible code. Let's break down those things, starting with clean code. So clean code are conventions. I like this diagram because it's kind of showing how like the broom is going to clean up, and but you kind of need to have some discipline, otherwise things get crazy. Clean code is all about consistency and organization of your code. So this can range from a wide spectrum. It can be things like white space, and thank goodness for libraries like Prettier and ESLint that can help us with a lot of the white spacing issues. The worst thing is when you have a PR and you say you're using 4 spaces and does 2 spaces and like you're spinning your wheels. And so white spacing, thank goodness, is mostly automated these days. Hallelujah. The way that we name things, so the way that we name our files, the way that we name our functions, and the way that we name our variables. There are some conventions that you follow. For example, whether to use camel case or hyphen case, kebab case, snake case. The way that we name our functions, so do we use verbs? Variables, do we use nouns? Booleans, do we use is, has, or can? Prefixes, all those kind of things are really good naming conventions so that while you're reading through code, you know what to expect. Another example would be these things called responsibility modules. And these are files that are typically named in the same way. They'll have the same file name, and they encapsulate a certain common pattern or group of code, such as if you're using TypeScript, you might put all your types inside of a types.ts file. Or if you're using an event bus, you might put all your actions or events inside of an actions.ts file. So that's just a way of consolidating and gathering together like code into one spot. So it's very consistent and intuitive for all the developers on the team. Another example might be function complexity and size. So just the fact that if you have smaller functions, it tends to be easier to reason about, and that can create cleaner code. People are less nervous about jumping in and changing. There are many other examples of clean code, but all of them are really intended to lower the cognitive overhead for the team. Or for you, if you come back 6 months later and have you ever had the experience where you think, oh man, what did I write here? This is crazy. I don't even understand what I was thinking. So you have a high cognitive overhead at that point, and you have to reread the code and kind of understand what's going on. That's an indicator of messy, dirty code instead of clean code. So we want to keep the cognitive overhead low so that we don't scream like this poster here. And we do that with things like convention over configuration, shared vision for where things go, straightforward onboarding. This really lends itself well to like checklists. So when you hire a new developer, you can go over, these are the conventions, A, B, C, and it's very fast. So what we try to do here is automate as much as possible, and then the fallback or safety net there is for code review comments for everything else that can't be automated for clean code. Again, just emphasizing that we automate where possible using ESLint, Prettier are very common. There's also good reference material from some authors who have written about clean code, such as Uncle Bob. Here are some common topics around clean code, like naming, commenting, function sizes, condition statements, error handling. All these things should be well established in the project and understood well by the whole team. All right, next, point number 2 is testable code. And this relates to a lot of patterns that we'll use in our code. Again, to make it testable and isolated. So testable code, why do we even test in the first place? Well, hopefully you're writing some tests because tests increase your confidence in the functionality and the performance of the system. So the way that we test code is through some patterns, and here are some examples that I've used work quite well. Some of these relate to React, some of them are more general, like vanilla JS. One pattern that's very testable because it's decoupled is an event bus. Basically, it's a signal that gets sent through the system, and usually it has a string for the event name and often a payload like an object for the body. And that event tells the system what happened, what event happened, and then the system can react. For example, really quick, UIs can use the event bus system when the user clicks on a button. The web component has a handler for the on-click, but instead of handling all the logic in that on-click handler, it can dispatch an event, and then other listeners in the system can then listen to that click event, and then they can do what they want with that event. So it's very decoupled, and it's very easy to test both the dispatcher to make sure that that event gets dispatched, as well as the event handlers, that they act correctly when that event gets sent. We'll talk a lot more about these. This is just an overview, so if these don't make sense yet, don't panic. We'll go over in more detail on future webinars and future YouTube videos. Another pattern is the container presentation components, like web components. This is because presentation or like template components are only concerned with rendering logic. So you can test that part to say, when I pass these properties in, does this label actually say this? Or does this button actually do that? Versus a container component, which is more business logic. And so you can mock things around that container, test what happens when those mocks change to see if the behavior of the component changes. Another pattern would be dependency injection. So dependency injection, I would say, is not super popular in JavaScript, and I understand why, because it seems very heavy, like heavyweight. However, dependency injection is really important. The critical thing about dependency injection is not just that you can change behaviors, but it's that you can swap behaviors in a test environment. So again, so you can isolate a component and mock out the things that you're not interested in testing, but just kind of assuming this is the way that this dependency works, and then testing the functionality of that component or that module or whatever it is you're testing function, and doing that really conveniently with dependency injection over things like mocks and spies and things like that. We can talk a lot more about this later. So those are some examples. Talking about testing, here's the ratio of tests that I've seen be very successful in the projects that I've worked on, is the test pyramid. So unit tests account for roughly 60% of the tests in the system. Integration tests account for about 30%, and end-to-end roughly 10%. We'll go over the definitions of these exactly, but think of unit testing as like testing an individual function. Integration about testing more of like the UI components along with business logic. So that's where they integrate, is UI and business logic. And end-to-end are browser tests. Specifically for unit tests, talking about code coverage is like 80% plus is a good number to try to hit. And this is to say when your test suites have all finished running, what code has at least been run once and what code hasn't been touched yet. It's really hard and usually diminishing returns to reach 100%. So somewhere between 80 and 90% is a good target. But remember that code coverage still isn't a silver bullet. So let's say you've reached over 80%. Doesn't mean you're testing well. It just means you're at least hitting lines of code. So it's a part of a complete picture for quality code and confident tests. So yeah, it's only a minimum threshold, but an important piece. Here we go. So unit tests are the fastest tests that should be running. They should be running in milliseconds. Like these are functions, you pass in some data and it returns a result and boom, 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 boom. You can just knock them out really quick. And so you can write hundreds and hundreds of these. If the sheer number starts to get really, really large and starts to get slow, your test should also be parallelizable by making them isolated so that they're never a problem running them all. Like it should be cheap to run and give you high confidence that individual parts are working, such as functions like utility functions or algorithms. You know, all the algorithms that we like to test during interviews. Those make really good unit test candidates. Integration tests, they can run for more than 1 second, 1 to 5 seconds. These, again, are where we're testing business logic and UI DOM integrations. And typically, you'll test web components in integration tests for front-end work. End-to-end tests are the slowest. They can take minutes to run. They are testing the full stack system. Usually nothing's mocked. And although you can, if it makes sense to, but normally you're trying to test every part of the system. So this would be something in staging or production. And yeah, like I said, they're done in browsers. You can do them headless or with a full browser tab open. There's pros and cons to both. Typically, what you try to run is the minimum set, which are called smoke tests. These are usually the happy paths for your system, just to make sure screens are up and working and your user doesn't hit 404s or other bugs in the system like payments never work, things like that, or common error cases. But yeah, really keeping the test case to a minimum helps to keep these naturally slow running tests from really slowing down the system and slowing down the testing over time as these just pile up and kind of multiply and get slower and slower. Okay, so we talked about the test pyramid and there's the code base diamond. So if you took a survey of all the code in your system, hopefully the ratios would work out something like this. You have a little bit of optimized code, you have a little bit of functional code, which isn't maintainable, but it's just working, and we can talk about reasons for that. But most of the code in your project, in your application, should be at a maintainable state. Maintainable meaning tested, refactored, and all these good things, like using design patterns to make sure that you can add new features with minimal churn. So this is sort of the ratio that we're hoping for in a code base. All right, finally, visible code. I think it's important to mention the documentation and making sure your code is understandable to humans and not just to machines. So the reason visible code is so important is because it creates faster time for understanding and context and troubleshooting for the team. Again, this is for the team. You might have all this IP locked up in your head, but we need a way to share it with teams, other developers on your team, so that if you're away or if you're busy, they don't get stuck and they're not spinning their wheels for too long. So a lot of sources for visibility and documenting your code. There's wikis, which I recommend for things like business requirements that a business or product manager can go in and edit as they see fit. There's readmes, which we're all familiar with. These are where we might share some higher context or some implementation reasons that that might not be intuitive by reading through the code. So again, it's like historical context goes really well into readmes. Also thinking about tickets. So the tickets that you're working on, those should have user stories in them, and that is a form of visibility and documentation about the feature that you're creating. Also, the PRs that you give with other developers are, the comments that people are sharing are also a form of visibility, and those should be captured and at least traceable through the ticketing system, as well as like demos. So if you think about either live or recorded demos that you give to your product manager or to your end customer, senior engineering manager, whoever, that is a way of providing visibility of your code, maybe not the statements or functions, but at least the functionality. And that is it. So becoming a senior developer is about mastering all of these aspects of maintainable code. Again, that's clean code, testable code, and visible code. If these topics interest you, please come back to the channel later. We'll have lots and lots more opportunities to share, discuss, and talk about the details, the techniques, the tools, and the principles around these things to help you get better at that. So if you like this webinar, remember to like it, subscribe to my channel, and make comments. And I'd love to hear your thoughts on any of these topics. And take care, and I'll see you all later. Hi everyone, it's Future Steve. I just want to say, first of all, I apologize for that last section. I feel like it got a little bit slow. And so I will try to keep the pace faster and the energy higher on my next upcoming videos. Just a little bit of self-critique there. But I had a couple of comments I wanted to emphasize or mention before I wrap up this video quickly. For visible code, I forgot to mention API documentation, which I think is great, such as OpenAPI or Swagger. Also, there are some documentation open source projects like Docusaurus and tons like it, which I think are great, JSDoc, etc. Also, I wanted to mention I forgot to tell why there are those red asterisks on the lists. If you go back, you'll see all those are topics that I intend to explore on this channel. So again, if this is anything that you're interested in learning more about, please come back and join me as we explore these topics more in depth. Because I think it's really important to understand all the tools that are available to senior developers in order to help them create better code, better quality code, and help those on their team who are junior to teach them. Like a perpetual flywheel kind of a cycle. Do you get me? Do you get me? Okay. Well, I look forward to seeing you in the next video. Take care.